Hi friends, welcome to my another video. Today in this video I will discuss how to set the Micrologic controller of MCCB for a motor. Sometime you may have faced some problem that the MCCB is tripping every time when you are starting the motor. The incorrect Micrologic controller setting can be the reason of tripping of motor every time. So in this video, we will learn that how to set this Micrologic controller as per our motor requirement. If you want to know in much detail about the Micrologic controller, then please watch my video Air Circuit Breaker Nameplate Detail. There I discuss each and every setting of the breaker and I elaborate in that what the purpose of this each setting. Link of that video will be in the description. In this video, we will take a motor and according to the motor requirement, we will set the MCCB Micrologic controller setting. So I took a motor which having a rating of 250 kilowatt and the power factor is 0.8. Of course, this motor is a three-phase motor, so the voltage will be 415 volt. Here you can see that there is a setting for L, setting for S, setting for I. Here the L setting is for long time setting and S setting is for short time setting. L setting will give protection against the overcurrent and the S setting, which is a short time setting, will give protection against the short circuit current. As the L setting is for the overcurrent setting, so what we will do, we will first calculate the full load current of the motor and based on the full load current of the motor, we will set this L setting. So let us calculate first the full load current of the motor. The full load current of motor formula is P divided by root 3 into V into cos phi for 3-phase. So what is the P value? It is a motor rating, that is 250 kilowatt. So I mention here 250 into 1000 watt divided by root 3 into 415 volt into 0.8 power factor. So the full load current came as 434.8 ampere. Now what would be the breaker rating? Breaker rating will be 125% of the full load current of the motor. This 25% is the safety factor in order to select the breaker rating. So the breaker rating came as 543.5 ampere. Here we have two options. The first option is we can go for a breaker rating of 600 ampere, which is the next available standard size breaker after 543.5 ampere. Or we can do another thing, that we can set this 800 ampere breaker as a breaker which having a breaker rating more than this. So with this L setting, we will set the breaker of 800 ampere to a breaker which having a breaker rating more than this one, 543.5. This IN is equal to 800 ampere is the nominal current rating of the breaker. But with the help of this L setting, we can change the nominal current rating of the breaker, which is called the rated current rating of the breaker. This breaker can handle till 800 ampere of current, but by adjusting the deep switches of the L setting, we can make this breaker as a 400 ampere, 500 ampere, 600 ampere based on our setting. So what is the advantage of that? If we will select a breaker which cannot be adjusted, suppose it is a 600 ampere breaker which is fixed one, we cannot adjust this rating, then if any load increased or decreased, then we need to change the breaker itself. But with this adjustment, we can adjust our breaker as per our load. And as you know well, the load is very dynamic. So this is the advantage of selecting a breaker which having a adjustment to change its nominal current rating, which is called the rated current rating of the breaker, by using the dial or this deep switch, which is coming under L setting. Now we will see how we will change this 800 ampere breaker to a breaker which having a current rating of 543 or above. So let's see. Here you can see that the I1 is given as IN into 0.4 plus 0.08 plus 0.16 plus 0.32. If we will sum up this one, then we will come to a rating of 800 ampere. But here my intention is to set this breaker as per our load current, that is 443.5 ampere, because after 443.5 ampere any current will be considered as a overload current for the motor. But if we will not set this breaker, then the current after 800 ampere will be the overcurrent for this breaker. So the breaker will allow the current of 543 and above till 800 ampere, and then it will trip, and meanwhile our motor will burn. So what is our intention? Our intention is to reduce this breaker rating as per our load requirement. These switches are called dip switch, DIP, dip switch. By adjusting this dip switch, we can change the breaker rating. Let us take, we turn this dip switch which is at 0.32 to 0, then the breaker rating will be IN into 0.4 plus 0.04 plus 0.08 plus 0.16. 0.32 will be neglected as we put this dip switch down at 0 point. So what would be our breaker rating? Will be 800 into 0.68 is equal to 544 ampere. In our previous step, we calculated the breaker rating after the calculation of full load current as 543.5 ampere, and after adjusting these dip switches in the L setting, we make this breaker setting as 554 ampere. So this breaker is now no more as 800 ampere. It will act as a breaker which having a breaker rating 444 ampere. So what is the conclusion? The conclusion is we adjusted this breaker as per our load demand, as per our load requirement. With this L setting, we give protection to the motor from the overload. Now, as we know that the motor at the time of starting taking very high current, that is called the inrush current. When there is no starter involved in the motor, then the motor usually takes 7 to 8 times higher than the full load current. But when we connect any starter technique like DOL starter, star delta starter, soft starter or VFD starter, then the motor will take less than 7 to 8 times of the full load current, which is given in this chart. When we will involve auto transformer starter to start the induction motor, then it will take 2 to 3 times of the full load current. When we connected the soft starter to start the motor, then it will take 3 to 5 times of the full load current. When we go for the dual starter, then it will take 6 to 8 times of the full load current. And when we will go for the star delta technique to start the motor, then the motor will take 2 to 3 times of the load. But when we will not go for any of the starting method or starting technique, then the motor will take minimum 7 to 8 times of its full load current, which is not good for the motor. Here the T1 setting is for the high inrush current which is coming at the time of starting of the motor. Here if T1 deep switch is up position, then it will hold the current which is 6 times of the selected rated current, that is 554 ampere, and when this T1 deep switch is below, then it will hold 6 times of 544 ampere of current till 12 seconds. So as we know that the starting current which is coming in the motor at the time of starting is temporary. It will maximum till 3 to 4 seconds, or for bigger motor it can be go till 6 seconds. So what breaker will do is, when we will start the motor and the motor is connected with the star delta technique, then the motor will take 3 times of its full load current. So our full load current is 544 ampere. Breaker will hold this current till 3 seconds if the dip switch is up, and the breaker will hold this current till 12 seconds when the dip switch is down. By that time, motor starting current will vanish and motor will take only full load current. So the breaker will not trip as the starting current get vanished before the 12 second. Though there is a high current, that is 3 times of the full load current at the time of starting of the motor, the breaker will not trip because of this T1 setting. As by adjusting this T1 setting, the breaker will hold to trip for 3 seconds and 12 seconds as per our adjustment, and by that time the motor starting current get vanished and it is taking only the full load current. So with this setting we avoided the undesirable tripping of the circuit breaker. This video in order to understand how the starting current come and vanishes within 3 to 4 seconds. As motor started, the starting current came and then it is stabilized to 96, 97, which is the full load current. Watch it again. Motor started, see the starting current coming as 327, but it's get vanished within 3 seconds to 4 seconds and it is stabilized to full load current. Hope you got this concept. S setting, that is the short time setting, is giving the protection to the motor from the short circuit fault. Here you can see that the short circuit current I2 is given as IN into 1 plus 1.5 plus 2 plus 5.5. If we will calculate this one 1 plus 2, 1.5 plus 2 plus 5.5, then it will be coming as 10. So this breaker, when there is a 10 time of the nominal current rating, that is 800 into 10 times, that is 8000 ampere, this circuit breaker give protection from the short circuit. But as per our load we have to adjust the dip switches. In my previous video, the topic was prospective short circuit fault current calculation. I discussed very thoroughly about the prospective short circuit fault current calculation. So here no point to repeat the same concept again. So watch that video and then come back to this video. Then you will come to know how I calculated the short circuit fault current for a motor. I explained in that video the prospective short circuit fault current in very deep. It is around 20 to 25 minutes video. So here again, if I will discuss same thing, then the video length will be more and there is no point to repeat it again. For the time being, just you accept that the short circuit fault current for the motor is 6 kilo ampere. It means when there will be short circuit, the maximum possible current can flow is 6 kilo ampere. For this circuit breaker, the capacity to break the short circuit fault current is 8000 ampere. But we have to adjust this circuit breaker as per our load short circuit fault current. So here you can see that if we will put this dip switch down, which is at 1, another dip switch that is at 1.5, we will put it down, and other two when we will put it up, then the short circuit current will be IN, that is 800 into 0 plus 0 plus 2 plus 5.5. That will be 800 into 7.5. When we will calculate this one, we will get the short circuit fault current 6000 ampere. So in that way we can adjust the circuit breaker as per our load requirement. Now, every time our intention should be to clear this fault as soon as possible. So we can set the time for this short circuit current as 0.1 second or 0.25 second by adjusting this T2 deep switch by taking it up or down. When the deep switch was up, then this short circuit fault current will be there till 0.1 second, and after the circuit breaker will trip. And when the deep switch will be down, then this circuit breaker will hold this current, that is 6000 ampere, till 0.25 second, and after that it will trip. So hope you got the concept how to make the Micrologic controller setting for a particular motor. I hope you got the importance of this Micrologic controller, as the incorrect setting will lead the continuous tripping of the motor, and if the setting of this Micrologic controller is wrong, then there is a chance also that your motor will burn out. I will give you one example here. Suppose all the dip switch is in the 0 position, then the rated current, IR current for this circuit breaker will be 0.4 into IN, that is 800. So it will come as 320 ampere. But as per our calculation, the rated current is 543.5 ampere. So what will happen? This breaker will trip every time when you will start the motor, because for this breaker the overload condition is after 320 ampere only, but your motor will take the current of 543, and during taking this current the circuit breaker will trip. Now let us take another example. Suppose all the deep switches are on, then the IR current will be equal to the IN current, that is 800 ampere, but your motor having the full load current as 543 ampere. So whenever the motor will take more than 544 ampere current, then for motor it is a overload current, but for the circuit breaker it is not an overload current. Then the circuit breaker will not trip, and this overload current will continuously flow through the motor, and it will break the insulation of the winding, and your motor will be damaged. Let us take another case also to have more better understanding of the importance of Micrologic controller. Suppose you set this I1 setting, I2 setting very correctly, but your T1 setting is wrong, meaning your motor having the starting current till 6 seconds, but you set the T1 setting at 3 seconds. Then what will happen? Whenever you will start the motor, it will trip. The circuit breaker will trip. Why? Because after 3 seconds also the motor is taking the high current, that is 3 times of the full load current in case of a delta starter technique. But for circuit breaker, as you set it wrong, it will feel that it is a overload current, and it will trip. Let us take another case, and after that we will summarize this video. Suppose the fault current of this motor is 6K. Okay, the prospective fault current at the motor level is 6K, but you set this short circuit fault current at 5 kilo ampere. Then when the short circuit will happen, the maximum possible short circuit current is 6 kilo ampere, but you set the short circuit current rating for this circuit breaker is 5 kilo ampere, though it is capable to take 8000 kilo ampere of current, short circuit current. But as per your wrong setting, the circuit breaker is capable to take only till 5 kilo ampere of short circuit current. Then what will happen? This circuit breaker will fail to operate, as the prospective fault current occur at the motor level is 6 kilo ampere. So circuit breaker will fail to operate, and finally the motor will burn out. I hope after watching this video you will not make any mistake in making the Micrologic controller setting for any motors. I hope you like this video and you feel this video is informative. If you really like this video, then please give thumbs up and subscribe to my channel. We will meet in any other informative video. Till then, take care, keep learning, and bye bye. Thank you so much.